Welcome data nerds. Today we are going to unravel a fundamental concept in computer science that you will encounter everywhere. From managing tasks in an operating system to handling requests on a web server. We're talking about the queue. So, what exactly is a queue? In the simplest terms, a queue is a linear data structure that follows the FIFO principle. First in, first out. Think of it like a line at a coffee shop. The first person to get in line is the first person to get their coffee and leave. The queue data structure works in the exact same way. The new elements are added to one end, often called the rear or tail, and existing elements are removed from the other end, called the front or head. There are a few core operations that define a queue. Enqueue. This is the process of adding a new element to the rear end of the queue. Dequeue. This is the process of removing an element from the front of the queue. Peek. This allows you to look at the elements at the front of the queue without actually removing it. IsEmpty. A simple check to see if the queue has any elements. Now for the fun part. Let's see how we can build a queue using a standard Python list. The great thing about Python lists is that they come with built-in methods that make this process quite intuitive. Now, let's start by creating an empty list to represent our queue. Simple enough, right? Now let's implement our enqueue operation. We can use the append method to add elements to the end of our list, which will act as the rear of our queue. As you can see, A, B and C has been added to our queue. Now, how do we get them out in the correct FIFO order, first in, first out? This is our dequeue operation. To remove the first element of the list, we can use the pop method with an index of 0. And there we have it. The first item we added was the first one to be removed. Let's try it again. Perfect. The FIFO principle is working as expected. What about our other essential operations? Peek is straightforward. We just need to access the element at index 0 without removing it. And for isEmpty, we can simply check the truthiness of the list. An empty list evaluates to false, while a non-empty list evaluates to true. While using a list directly works, it's good practice to encapsulate our queue's logic within a class. This makes our code more organized, reusable, and easier to understand. Now, let's create a simple list queue class. See how much cleaner that is? Now we have a dedicated object for our queue with all necessary methods. So, using a list as a queue is simple and it works, but is it efficient? This is where we need to talk about time complexity. Our enqueue operation, which uses append, is very efficient on average. It has a time complexity of 0, 1, meaning it takes a constant amount of time regardless of the size of the list. However, our dequeue operation, which uses pop with an index of 0, is a different story. When you remove the first element from a Python list, every other element in the list has to be shifted one position to the left. This means that the time it takes to dequeue an element is proportional to the number of elements in the queue. We say it has a time complexity of 0n, where n is the number of items in the queue. For a small queue, this might not be a big deal, but imagine a queue with thousands or millions of items. That shifting process can become very slow and impact the performance of your application. So, if the list-based queue has performance issues, what's a better solution in Python? The answer is the dequeue object from the collection module. Dequeue stands for double-ended queue. It's a specialized data structure designed for fast append and pops from both ends. Let's see it in action. The key here is the pop left method. Both append and pop left on the dgive object has a time complexity of 0, 1. This makes dgive a much more efficient and recommended way to implement a queue in Python. And that's a wrap. Let's quickly recap what we learned. A queue is a first in, first out data structure, FIFO for short. And we can implement a queue in Python using a simple list with append for encoding and pop for dequeuing. While easy to understand, using a list for a queue can be inefficient for dequeue operations due to its own time complexity. For a more performant queue in Python, it's highly recommended to use the collection dequeue object, which provides O1 time complexity for both adding and removing elements from either end. Understanding the trade-offs between different implementations is a crucial skill for any developer. While a list queue might be fine for small-scale applications or quick scripts, knowing when to reach for a more optimized tool like dqueue will make your code more robust and scalable. Finally, if you found this video helpful, you don't have to like or subscribe because this is an educational channel. I don't care about the metrics. But please let me know in the comments if you have any questions or topics you would like to see covered next. Happy coding. Bye.